4 minus 1, that's 3, quick maths. Everyday man's on the block, smoke trees. See your girl.
Myself Sujay Kumar, mathematics teacher, Modern English School, New Area, Nevada. Welcome students to e-learning classes managed by Modern English School, Nevada. Dear students, today I discuss some remaining problem of examples of 7C. It is all related to the similarity and the areas theorem. So dear students, see here towards the board. Here is example 7C, question number 9. Question is ABCD is a trapezium. ABCD is a trapezium in which AB parallel to DC and AB is equal to 2DC. That means this AB, length of AB is 2 times of DC. Diagonals of trapezium intersect at O. Then find the ratio of the triangle AOB and COD. That means you have found the ratio of areas of triangle AOB and triangle COD. This question is related to area. So first to find the relation of similarity of these two triangles. So I write here first triangle AOB and then triangle COD. In AOB, angle 1 is equal to angle 2. That is angle interior, alternate interior angle. Next 3 is equal to 4. That is also alternate interior angle. Then both are triangles similar by AA property. So triangle AOB similar to triangle COD by AA property. If two triangles are similar, then you remember it first theorem of area. Then the two triangles are similar, then their ratio of their areas is equal to the square of their corresponding sides. So I write ratio of their areas AOB by area COD is equal to AB square by CD square. Then it is equal to, at the place of AB, 2CD whole square by CD square. Then 4CD square, then CD square cancel, then 4 by 1. Therefore, area AOB ratio area COD is equal to 4:1. It is yours. Second question of the example, that is question number 11. It is D, E and F. D, E and F are the midpoints of the sides AB, BC and AC respectively. That means D is the midpoint of AB, E is the midpoint of BC and F is the midpoint of AC. And you have to prove find the area relation between ABC and triangle DEF. That means this is a large triangle and this is a small triangle. What is the area relation between them? So dear student, first to find what is the similarity relation between them. So first to find similarity, then find the area relation between them. First we write here, let ABC is a triangle such that D, E and F are the midpoints of the sides AB, BC and AC respectively. Say D is the midpoint of AB and F is the midpoint of AC. Therefore, DF parallel BC and DF is equal to half BC. D is the midpoint of AB and F is the midpoint of AC. That means this DF is parallel to BC and half BC by MPT. By MPT, midpoint theorem. This is midpoint, then this line remains is parallel to the third sides of the triangle and half of it. So I write DF parallel BC and DF is equal to BC by 2. If DF parallel BC, then DF parallel BE and DF is equal to BC by 2, that is DF is equal to BE. So DF parallel BE and DF is equal to BE, is therefore BDEF is a parallelogram. I write here, so BDEF is a parallelogram. If it is a parallelogram, this is parallel and equal, then it is a parallelogram, then this angle B is equal to angle F. It is opposite angles of parallelogram are equal. If it is equal, similarly ADEF is a parallelogram because these are the parallel and it is also a parallelogram, then this angle is also equal to angle A. So by A similarity, triangle ABC similar to EF. That means these small triangles are similar to this large triangle. So your area is DEF to ABC. So we know that area triangle DEF divided by area triangle ABC is equal to, you write DEF, you write here DE square by BC square. Next, it is DA square, and this BC you can write 2D by midpoint term. This DE square, here is BC, you write sorry, DF square is BC square. So this DF you write 2DF. Here is D and here is F. Then DF is the half of BC. This DF is equal to BC by 2. Then 2DF is equal to BC. So I write here DF square by BC square. This BC you write 2D. Then what you get here DF square by 4DF square. DF cancel. It is 1 by 4. Then you can write area triangle DEF ratio area triangle ABC is equal to 1:4. That is your solution. Now see question number example 12. Question is that prove that the areas of an equilateral triangle described on one side of a square is equal to the half the area of an equilateral triangle described on one diagonal of a square. Here ABCD square and one equilateral triangle on the side BC of the sides, that is BCE, another equilateral triangle of the diagonal AC, that is ACF. But both are equilateral triangle. And your questions, the area of BCE on the side is equal to half the area of ACF on the diagonal. Means area of triangle on the side is half the area of the triangle on the diagonals of the square. So dear students, first you write ABCD is square, AC the diagonal, and two equilateral triangles are formed on the side BC of the square ABCD and the diagonal AC of the diagonal of ACD. So one triangle is BCE, another triangle is ACF. But both triangles are equilateral. If both triangles are equilateral, one is BCE, another is ACF, then it is a equiangular. That means similar. All equilateral triangles are similar to each other. So no any reason that you can describe here that triangles are similar. Only if it is equilateral, then it is similar. So write here triangle BCE similar to triangle ACF. That means both are equiangular. Both are equilateral. So it is similar. If it is similar, then by areas theorem, the ratio of the areas of two similar triangles is equal to the square of their corresponding sides. So area of BCE by area of ACF, area of BCE by area of ACF is equal to BC square by AC square. And suppose here BC be x and AC be root 2x, because diagonal of a square is root 2 into sides. Side be x, then diagonal is root 2x. So I put their value x square by root 2x ka whole square, that is 1 by 2, and then this ACF goes this side, that is area of triangle BCE is equal to half area of triangle ACF. That is so. Now see question number 13, that is prove that the areas of an equilateral triangle described on a side of a right angle triangle is half the area of equilateral triangle described on its diagonal. Here is given a right angle triangle and that is isosceles. That means these and these sides are equal and it is the hypotenuse of this right triangle. One equilateral triangle formed on the side, that is BCD. Another equilateral triangle formed its diagonal, hypotenuse, that is AC. Your question is the area of BCD is half of area AC. First we suppose here let ABC triangle angle B is 90 and AB is equal to BC is equal to x. AB is equal to BC is equal to x. So first we find AC, that is AB square plus BC square, x square plus x square, this is 2x square, this is root 2x. Now two equilateral triangles are formed described on the side BC and AC. These two equilateral triangles are formed. If these are equilateral triangles, then it is clear the both triangle are similar. So triangle BCD similar triangle ACE, because both are equilateral triangles, then it is similar. Now write area of triangle BCD by area triangle ACE is equal to BC square by AC square by area itself. Ratio of both two similar triangle of areas is equal to the square of their corresponding sides. So area of triangle BCD by area of triangle ACE is equal to x square by root 2x whole square, that is x square by 2x square, that is 1 by 2. So area of triangle BCD is equal to half area of triangle ACE. That is proof. It is your question. Now see question number 14. That is, if D is a point on the side AB of triangle ABC such that AD is to DB, AD to DB is 3:2, and E is the point on BC such that DE parallel to AC, then find the ratio of the areas of triangle ABC, large triangle, and triangle DB, a small triangle. Dear students, first here given ratio AD is to BD. So I suppose here AD is equal to 3x and BD is equal to 2x, because given the ratio form. Therefore, what is AB? It is 3x, it is 2x, then it is 5x. Now DE parallel AC. So these angles are corresponding angle and equal. So D is equal to A, corresponding angle. And you write here corresponding angle also. And similarly, E is equal to C. It is also corresponding angle. So triangle DB, a small triangle, are similar to ABC. So these are the similar triangles. If these triangles are similar, then area of the similar triangle is the square of their corresponding side. So area of DEB by area of ABC is equal to DB square by AB square. And DB is 2x and AB is 5x. So I write 2x by 5x whole square, that is 4 by 25. But your question is first ABC and then DB. So I write first ABC and then DB. Then it is 4 into 25. Now you write 25 is to 4, because it is DB then ABC. But your question is ABC then DB. So you write in the reciprocal form. So area of ABC by area of DB is equal to 25 is to 4.